Hello everyone, I'm Adam. In this problem, for our system of inequalities that we have here, x minus y squared greater than 0 and x minus y greater than 2, we want to sketch a graph of the solution set of that. And again, what the solution set is, it's the set of all points x and y that simultaneously satisfy each of the inequalities that we have. And so what we're going to do is find the solution set of each inequality individually and essentially look at where they overlap or intersect. So we'll start with our first inequality. So x minus y squared greater than 0. And we notice, well, if we can add y squared to both sides, we get x is greater than y squared. Now, one of the things we do with these inequalities, is we can consider the equality. So here, x equals to y squared, and kind of use this to help us find the solution set. So what is x equal to y squared? What is the graph of that? Well, we know what the graph of y equals x squared is. It's our parabola, right, with axis of symmetry with the y-axis and vertex at the origin. But x equals y squared is the same parabola, just rotated 90 degrees, where we're opening up along the x-axis, and still with our vertex at the origin. So basically what a graph of x equals y squared is going to look like is our parabola opening up this way. And we're just doing a basic sketch. We'll do a more rigorous one in a little bit. So this is our graph of x equals y squared. Now we want to find the solution set to x greater than y squared. Well, that's all values x that are greater than, right, the value of y squared, which is represented here. Now we're using a dotted line because we have a strict inequality, not greater than or equal to, so we're not actually including any points on this curve, just all points that will be greater. And so our solution set, or our region, is going to be all points kind of inside our parabola, kind of thinking of it that way. So that's the solution set to our x minus y squared greater than 0. Now what about our next inequality, x minus y is greater than 2? So let's take a look at that. Now here we don't have anything being squared, we just have x to the first and y to the first. So we can kind of write this, right, as something linear, or bring everything over to one side and sort of solving for y. So if I subtract my x, I'll have negative y greater than, say, negative x plus 2, and dividing both sides by a negative, we'll have y less than, say, positive x minus 2. And again, we'll consider the equality, y equals to x minus 2. And what can we do with that? Well, that gives us the graph of a line. So if we consider y equals to x minus 2, well, we're going to have y-intercept at negative 2, and with slope being 1, we can go up 2 over 2. We'll cross the x-axis at positive 2. And so get our line y equals to x minus 2. Okay. Now, what points in this solve the inequality y less than x minus 2? It's going to be all values or all points below the line. So it's going to be all points below this line. And again, it's a strict inequality. So our dashed line represents that we're not including the points on the line there. So here's our two solution sets. And so the solution set to our system is going to be where these two parts overlap. So what we're going to do is essentially graph our our line and our parabola in one graph up here, and then see what region overlaps with both. So let's start with our, say, equality x equal to y squared. So we're going to have vertex, say, at the origin. And now when y is equal to 1, right, x equals y squared is 1. And when y is equal to 2, x equals y squared is going to be 4. And likewise, when y is negative 1, x will be positive 1. And when y is negative 2, x will be positive 4. So our parabola, just sketching it back in, again, we're using a dashed line and open dots because the points on this parabola are not included Okay, so we get that. And next, look at our line y equals x minus 2. So again, y-intercept at -2, up 2 over 2, cross the x-axis there, at x equals 2. So kind of sketch in our line. Again, open circles and a dashed line because we're not including any of the points on this line either. There's our line y equals x minus 2, and our parabola for x equals y squared. Okay, so what's going to be the solution set for our system? Well, for x minus y squared greater than 0 by itself, it was all points kind of on the inside of our parabola. And for x minus y less or greater than 2, it was all points below this line. So where do they intersect? Well, all points below the line and inside the parabola looks like we're going to be in this region here. So below our line, going all the way down to our parabola, but not going past it. And continuing on as we pass the line, staying inside our parabola as x goes to positive infinity. So there is our solution set, or a graph of our solution set. So thank you very much.